Welcome to the deep dive. Today we're tackling something really critical, architecting Amazon Redshift,
Hmm.
specifically for financial analytics where security and compliance are just, well, non-negotiable.
Absolutely. It's a tough balancing act, isn't it? You need those fast insights, that real-time data, but you absolutely cannot afford to slip up on security or regulations. The consequences, especially in finance, are huge.
Exactly. And we've got a great source article here that kind of lays out a roadmap for building that robust Redshift setup.
Yeah, it's a solid guide. It really digs into how you can get the analytics power you need while meeting those, really stringent demands.
Right. So our mission for this deep dive is basically to pull out the key strategies from this guide. We want to give you the core knowledge needed to confidently approach building a secure, compliant platform on Redshift for finance.
Sounds good. Where should we start? Maybe the foundation.
Yeah, let's do that. The foundational infrastructure. The article really hammers home deploying Redshift inside a private VPC. No public internet access. Why is that step one?
Think of it like building a vault first. A private VPC basically isolates your Redshift cluster from the public internet. It drastically shrinks the attack surface. It's your first big security wall.
Okay, isolation first. Then the article mentions security groups and VPC endpoints.
Right. So security groups act like instance-level firewalls, your virtual bouncers, controlling exactly what traffic can get in or out of the Redshift nodes themselves.
Got it. And the endpoints.
VPC endpoints, they're crucial. They let your Redshift cluster talk securely to other AWS services like S3 without that traffic ever leaving the AWS private network. You're creating secure, private pathways. And a pro tip here, make sure you use the right type of endpoint, maybe gateway or interface, depending on the service, to really lock things down.
That makes a lot of sense, building layers of security. And encryption is mentioned next, end to end. It's not just one or the other.
No, definitely not. You need both. Encryption at rest protects the data when it's just sitting there, stored on the disks within the Redshift cluster. And then encryption in transit scrambles the data while it's moving, to and from Redshift. So queries going in, results coming out. It's like having locks on the vault and on the armored car moving the money.
Good analogy. Okay, vault built, data locked down. How do we manage who gets the keys? That sounds like IAM territory.
Exactly. Identity and access management, or IAM, this is absolutely critical. You need strong IAM policies built on the principle of least privilege,
Meaning?
meaning users and applications only get the absolute minimum permissions they need to do their job. Nothing more. And integrating with your existing identity provider like Okta or Azure AD is really best practice. It centralizes user management and strengthens authentication.
Right. And what's a common mistake people make here?
Giving analysts maybe overly broad read access to everything. You really want to scope that down. Be specific about what tables or schemas they can actually query.
Makes sense. So, okay, that's the external setup, the infrastructure.
Yeah.
What about Redshift itself? What built-in security features should we be using?
Well, first off, audit logging. You absolutely need to enable detailed logging. It tracks every single query, every access attempt, who did what, when, from where. It's vital for security monitoring and for proving compliance to auditors.
So traceability is key.
Totally. And then you have the SQL level permissions, good old grant and revoke statements. These let you get really granular within the database itself, controlling access right down to specific tables, views, even columns sometimes.
Oh, okay, so layers of access control.
Yeah.
Infrastructure and database level.
Precisely. And don't forget Redshift data sharing. This is a really neat feature for collaboration.
How does that help with security?
Well, instead of the old way, like copying massive data sets between departments or accounts, which, creates more copies to secure, more risk.
Right, it increases the surface area.
Exactly. Data sharing lets you provide secure, often read-only access to live data in your cluster without actually moving or duplicating it. It's like giving someone a secure window to look through rather than handing them a copy of everything. Much cleaner.
That sounds really efficient and secure. Now, something else the article brings up is this link between performance and security. How do those connect? They seem like different goals.
It's an interesting point, right? But often, a well-architected, high-performing system is actually inherently more secure and reliable. Think about it. Choosing the right node types, like the RA3 nodes, which let you scale compute and storage separately, means better resource use.
Okay.
Designing your distribution keys and sort keys smartly makes queries run faster and more efficiently. Tuning workload management, WLM, ensures your critical analytic queries get the resources they need, preventing system overload.
And how does that efficiency translate to security?
Well, a smooth running system is generally easier to monitor. Anomalies stand out more. Plus, performance bottlenecks can sometimes lead to unstable states or encourage risky workarounds, so good design benefits both speed and security.
That's a great point. Can you maybe walk us through a quick real-world example? How might a bank use this?
Sure. Imagine a global bank using Redshift for, say, real-time credit card fraud detection. Their setup would likely involve Redshift tucked away in a private VPC. Very specific, scoped IAM roles for the applications feeding transaction data, maybe streaming from S3 or Kinesis.
Okay.
Detailed audit logs tracking every single query against that transaction data. They might use materialized views to pre-compute aggregates for those instant fraud dashboards analysts look at.
For speed.
Exactly. And then the fraud investigation team, who maybe needs deeper details on specific transactions, they might get access via Redshift data sharing, giving them just the slice of data they need securely.
So pulling it all together, and what's the payoff for the different people involved in that bank?
For the business leaders, it means faster, reliable insights for fraud detection and fewer headaches during compliance audits. For the tech teams, it's having a scalable, robust architecture they can trust, one that meets strict regulatory requirements without slowing things down.
It really feels like that combination is just table stakes in finance.
Oh, absolutely. It's not a nice to have, it's a fundamental requirement. You just can't operate otherwise.
So wrapping this up then, if someone listening is thinking about architecting Redshift for financial analytics, what are the three absolute core pillars they need to focus on?
Okay, three things. One, nail the foundational security. Private networking, VPCs, encryption everywhere, and really strong IAM with least privilege. Get that base solid.
Right, the vault.
Two, leverage Redshift's own security tools fully. Turn on audit logging, use those fine-grained grant revoke permissions, explore data sharing for collaboration. Don't ignore the built-in features.
Makes sense. And the third?
Third, architect for performance from the start. Choose the right nodes, design your tables smartly, tune your workloads. Remember that efficiency and security often go hand in hand.
Excellent summary. Foundational security, leverage native features, and design for performance. And maybe a final thought for you, the listener. Take a moment to consider your own data strategies. How proactively are you weaving security and compliance into design right from the beginning, alongside performance? It's something that really demands upfront attention in today's world.